The design brief says we need to design a flow diagram that will allow an LED to blink. Now, further detail stipulates that the duration of each blink should be half a second and the period between blinks should be a total of 1 second or 1 hertz. So firstly, we need to identify we are going to use B0 as our output. Now when we start the program, the output is off. So we're going to bring in an output, double click on it, and we say B0 must turn on. Then we add the wait command, and the duration must be half a second that it's on. Sorry, that was the wrong command there. High, and that must be B0. B0 stays on. Let's just link these two. Then it has to turn off for, or turn on for half a second. Then B0 must turn off. Then we wait again for half a second. That gives us a total period of 1 second. Once that's completed, we add a line, which then takes us back to the start. So when we simulate over here, we see that once it's loaded, program starts, high, wait, low, and we can see there that B0 turns on and off, and on and off. Now the additional design brief now indicates that we need to add a start and stop function to this. So I'm going to start a new flow diagram. C's are my inputs, B's are my outputs, and we've got the start over there. Let's say C2 is my control pin. So initially what happens is we need to take a decision to see, is C2 active? If C2 is 1, in other words it's on, then the output, again let's make it be 0, will turn on. We will wait half a second, and then it has to turn off. However, the design brief isn't specific as to when it must turn off, so I'm going to add a second decision so that it checks the value over here at that point of that was C2. Okay, so I'm just going to add a comment for myself there. Add a comment, check C2. Okay, so there we're checking for the value of C2. If it's on, then we continue with the program. If it's off, we're going to add a line that's going to take us back so that it rechecks there. Once it gets the yes or 1 on C2, then it turns the output on. It waits half a second and then it checks again what is the value of C2. So we're checking there, is C2 still 1? If C2 is still 1, then we continue with the program. So we're now going to turn the output off. That's B0. We're going to turn off, and we're going to wait again for half a second, and once that's done, we will then repeat the whole program. So this decision over there needs to return back to the top, and then after this wait again we still return to the top. So we've got 3 loops. So when we simulate, run the simulation, it goes from the start. Decision says that C2 is not active. So when we activate C2, it now runs through the program, turning on, turning off. You can see there B0 turns on, and then it turns off, on, off repeatedly, and that will continue until I turn the value of C2 off. Once C2 is inactive, it will stay in there. Let's just make sure that this step over here, this decision, runs correctly. So C2 is active, and yes, once we active and deactivate there, it runs through there and it goes back there. Problem is now B0, the output remains high. So in order to overcome that, let's just put a loop in here. Let's just add a loop in there. It's going to say, irrespective of what happens there, let's force B0 to turn off. We don't want a delay there, it needs to turn off immediately, and we're going to run that back over there. And we should not have these lines over there. So let's quickly do a final rendition or simulation. We see run, starts, there's no decision, let's take the decision and it runs through, turns off, returns to low, output is functioning correctly. So let's just, when it gets to this section, there we go, and it runs through and we see the output has turned off.